In this video, I'll be solving the 10th problem of AIME first session 2025. So we were given a Sudoku puzzle where each row can take all the different numbers from 1 to 9, and each table or each block of columns should also contain all the numbers from 1 to 9. So we need to find the number of ways of filling this particular Sudoku puzzle. So first of all, so if we consider this, so basically for my problem, I'm like breaking it into 3 blocks. So basically this is like block 1, and this is block 2 and block 3. So in my solution, I'm just like breaking them into 3 column blocks, and row, like we can, this is like row 1, row 2, row 3, because like we also have to ensure that block thing, because it's not just arranging like 9 digits. We also need to ensure that 9 different digits are there along the rows, and they are also there inside the columns. So the top row can be the permutation of this 1, 2, 3, 4. So top row is like very easy one. So it's just permutation of this 9. So 1, 2, 3 and so on till 9. So this can be done in 9 factorial ways. So it's just total permutation. So for row 1 we have 9 factorial choices. Now if we consider the row 2, since we have divided the Sudoku of 9 columns into 3 column blocks, like block 1 is 1 to 3, columns 1 to 3, block 2 is columns 4 to 6, and block 3 is columns 7 to 9. So now in each block, in row 1, like we already uses like 3 digits. Now the remaining 6 digits of each block, we have to fill it in rows 2 and 3 of that particular block. So let's say, like, let's consider this example only, 1, 2, 3, 4, 5, 6, 7, 8, 9, where, so now like this particular 1, 2, 3, they can go into either block 2 or block 3. So let me use some other color for the second part. So if we are having like 1, 2, 3, so they can go into like either block 2 or 3, since they can't go back to this block 1. And similarly, if we consider like 4, 5, 6, they can go into block 1 or 3. I mean, this is just for an example. And similarly 7, 8, 9, so they can go into like block 1 or 2. For this specific case, I'm just saying so that we can generalize it based on this particular thing. So now row 2 can contain exactly 3 digits in each block. So that means, let's say like A digits, like some A digits from this 4, 5, 6, suppose they are going to like for block 3. Some A digits are of this 4, 5, 6 are going to block 3. And let's also say out of this 1, 2, 3, again like some A digits are going to this. So let's say like from 4, 5, 6, let's say if they are going to block 1, and from or it doesn't matter actually, 1, 3 or 3, 1, like it doesn't matter. So let's say A digits of 1, 2, 3 are going to block 3, and A digits of 4, 5, 6 are going to block 1, because either 1 digits can go, or 2 digits can go, or 3 digits can go, or none of the digits can go to either block 1 or block 3. So the same thing happens like even in 2 or 3. So this means like 3 minus A digits should go to like block 2, right? Or A digits, sorry, not block 2. So A digits, 3 minus A digits from the 7, 8, 9 should go to block 1. So because like A digits are going from block 3, so 3 minus A digits should go to block 1. So we can understand this, like why we are considering only A, 3 minus A. Suppose like we are having this is block 1, block 2, block 3. So from this 1, 2, 3, suppose A digits are going to block 3. Now that means 3 minus A digits have to be filled here. Now in block 1, like A digits are going to block 1 and 3 minus A. So that means the remaining digits A and 3 minus A should obviously go into this block 2. So that is the reason why we are considering the same parameter A. Like instead of, like, I can also write B digits here, but like in the end, like if we compare for the third one, we'll be getting like A is equals to B. So that is like one key thing that we need to understand, because even the blocks are related here. So the total set of choices will be, so here like we will be having 3 choose A into 3 choose A into 3 choose 3 minus A, sum taking over from 0 to 3. So that means it is just A is equals to 0 to 3, 3 choose A whole cube. So that is nothing but 3 choose 0 whole cube plus 3 choose 1 whole cube plus 3 choose 2 whole cube plus 3 choose 3 whole cube. So that's nothing but 1 plus 27 plus 1, which is 56. So there will be like 56 ways for deciding like which digits go to like block 2. So now, so basically block 2 we are done. Now like with each block, like now within each block, so basically now like if we arrange the digits, like 56 ways of arranging the digits in the respective blocks of row 2. So that means the residual number, the 3 digits will be left for each block. So obviously there will be going to the third block, because like first what did we solve? Like this is, we solved for first row, and this we have solved for the second row. So for second row, like we have solved. Now for second and third row, so first row, like our order, like we're fixing one order, and based on that we are deciding for the second and third order. So now like for the third step, so what am I doing is I'm ordering rows inside each block. So within each block, so like row 2 can arrange its digits, its 3 digits in 3 factorial ways. So that means like row 3 automatically gets the other 3 digits, and that is also permutable, right? Because row 2 we have already arranged. So row 3 I mean automatically gets the residual, the residual 3 digits respectively, like for different blocks, respectively for 3 blocks will be left over. So for row 3 also we can arrange its digits in 3 factorial ways. So for each block we can arrange, like for row 3, so here we have 3 factorial and 3 factorial. Like row 1 we already arranged, so we don't have to worry. So row 2 we are arranging 3 factorial. So same way, like row 3 also we can arrange 3 factorial. So that means here 3 factorial whole cube into 3 factorial whole cube. So that is nothing but 6 cube into 6 cube, which is 6 to the power 6. So the 6 to the power 6 ways are there for rearranging the like elements in row 2 and row 3. So basically here we are like arranging. So in this third step we are arranging row 2 and row 3, like different arrangements, different ways of arranging row 2 and row 3 elements. So that means the required total number would be, so like first row 1. So row 1 there are 9 factorial ways to arrange. The second thing is which digits to arrange in which digits, like different ways of assigning the digits to blocks for row 2. So that is 56. And the rest is arranging row 2s and row 3s inside the blocks, that which is 6 to the power 6. Now 9 factorial, if I prime factor is like 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 into, this is 7 into 2 cube into 2 to the power 6 into 3 to the power 6. So that means here 2, 4, 6 and 8 we can get 2's. So that means 1 plus 2 plus 1 plus 3. So that is nothing but 2 to the power 7 into 3 square into 3. So that is 3 cube into, we have 1 5 and 1 7. So this is 9 factorial into 7 into 2 cube into 2 to the power 6 into 3 to the power 6. So that is nothing but 2 to the power 3 plus 6 plus 7. So that is nothing but 6 plus 3, 9 plus 7, 16. 2 to the power 16 into 3 to the power 4 plus 6, which is nothing but 3 to the power, it should be 3 to the power, 3 to the power 4 this should be, because like we're having 3, 6 and 9. So 3 to the power 4, 9 contributes to. So this is 3 to the power 4 plus 6 into 5 to the power 1 into 7 to the power 1 plus 1. So that is 2 to the power 16 into 3 to the power 10 into 5 to the power 1 into 7 square. So this is our p to the power a into q to the power b into r to the power c into s to the power d. And like p, q, r, s are distinct primes as given in the question. Now like we need to find what is p times a plus q times b plus r times c plus s times d. So that will just be 2 into 16 plus 3 into 10 plus 5 into 1 plus 7 into 2. So that is 32 plus 30 plus 5 plus 14, which is nothing but 62 plus 19, which is nothing but 81. So the answer for this question would be 81. So basically we are arranging the permutations of different rows, like finding the assignments, different digit assignments, and then arranging the rows in second and rows 2 and 3 inside the blocks. So the answer for this question would be 81. So that's it for this video. We'll meet in the next video.